Alright, welcome to this short video tutorial series on the tool called Aeroflow. If you know a bit about CFD analysis, if you do it, you probably know that pre-processing can be a real pain. There's a lot of work required, a lot of manual labor usually, especially if you are trying to build a good mesh. And this tool, what it actually is about, is it's supposed to automate as many steps as possible. So just to have a quick look at what it can do, on the screen you see, I mean, this is like the base model that is implemented, just to show what we're talking about, what this simulation stuff will give you in a very short time frame. And below here we see the basic structure. So depending on how you specify your input, it might be a proprietary format that we use at our university. If you use that, you can just put it in. MATLAB will convert it to a CPAX definition. If you have a CPAX definition already or you want to use it, then perfectly fine, you can tailor the tool to implement that. Once you have that CPAX definition, we can go on and put it into Tegel. This will generate a CAD model, a step model, and that step model, together with an ANSYS journal file that would be automatically generated by this workflow, that will go into ANSYS Fluent Meshing. So ANSYS Fluent Meshing will build a base mesh, very rough representation just of the surface basically. So you won't have any volume refinements like you normally would. And the reason for that is that this workflow will implement adaptive meshing. So once you've got that initial mesh, you've got another ANSYS journal file that will be used for taking the parameters that you set into the workflow. And that will go into ANSYS Fluent. So ANSYS Fluent will start up, get the base mesh and get the parameters that you told it to use, and then it will start solving. Once it starts solving, it will see where we've got big gradients in the flow field, and then it will refine in these places. Just a very broad overview now. If you want to know more, there's a user developer documentation available where I go into a little more detail. But other than that, this tool and this tutorial series is really just to show you how this workflow works, how this automation stuff works, because everything you just heard will just be one click of a button and will run all the way until the end, until you get the results. If you want to know more about the details about AMR, for example, this is not the place where you get that information, but there's plenty of it available on the internet. So have a look at that. Now, talking about the structure of this tutorial series. We've got the introduction. We've got a few notes on the installation, just very quickly. Then a first look at the tool. I will show you around, show you what files you will find. I mean, it's a collection of scripts really, and you will see what that looks like. Then we will run your first simulation, see how easy it is actually, view the sample results from just a sample case, the one that we see here, and then, I mean, that's the easy part. That's just seeing how it all goes. But if you want to work with it, you will want to change the settings. So you will want to change the geometry, change the meshing settings, and change the solution settings. And the big thing about this tool is that you have got an easy access to those parameters, and just an easy interface without having to open all the user interfaces, for example. But you will see more about that when we get there. And the last part I will cover is skipping the geometry conversion. That means if we do not have the proprietary input format that I mentioned in the beginning, and we just want to use CPAX definitions or our own parameter set, for example, then I will show you how you can deactivate the conversion and run it in an easier way. So I guess that's it for the overview, and let's get started with the notes on installation.